Hello and welcome to another tutorial. So this time around we are going to be making a basic grappling mechanic. So the idea in this case being having essentially an item that the player can use to grapple onto something and pull themselves to that. So we're going to be setting up a few things for this. Part of it is going to be that actual tool and a lot of the logic for that. Part of it's going to be some stuff then for adding additional markup onto the particular surfaces we want to be able to grapple to. Because we probably don't want to allow players to be able to grapple to anything. And we also may want to have things like, okay, you can grapple to it, but only for a certain length of time. So we're going to add in some additional functionality to support that. We'll also add in support for a little bit of player feedback. So being able to indicate when you're looking at something, okay, is this something I can grapple to? Is it something I can't? Is it a time-limited grapple? Little bits of information like of that we can potentially convey to the player, which can make it a lot easier. So let's dive on in. So I already have a bit of a scene set up here, and I've already imported a few additional packages to this. So I've brought in things like Cinemachine, I've also brought in the new input system, and I've brought in a basic first-person character controller. Now, if you're wanting to grab this project, what I have done is I have exported a package for these third-party things like the character motor of mine, and I've put a link to that in the description below. So what I will go through is the process of, okay, how do we then use that package in the scene? I didn't want to spend too much time on the actual character controller. The reason being is you might be wanting to use this with a different character controller, so I've tried to keep the logic fairly separate so you can easily use it with other ones. And just made it there as a full package. So if you're wanting to start at the point that I'm currently at with this, that already has that package imported, there is a link in the description below. You can download that, and so you can just start from this exact point. Or if you're wanting to start with your own basic scene and import stuff, because at the moment this scene is just a plane and objects that I've added some extra materials to just to make them stand out. So that's something where if you're wanting to just go with this very bare bones and create your own project, you might want to import that package that I set up, or alternatively, like I said, you can just grab the version of this at this current point from the description. So first thing I need to do with having this character motor package is I need to actually make sure that I can move around the scene. So I'm going to bring in my player. Now I'm also going to bring in, because I want to have the reticle, that HUD indicator, I'm going to add in an image, and this will be our reticle. And if we go to the game tab, that'll make it easier for positioning this. So I want that to be positioned in the center. I'm going to change the sprite to the knob one, and size-wise will depend on the resolution and everything you're building this at, but I'm going to go for 30 by 30. I will also turn this off being a raycast target because I specifically don't want the reticle to be a raycast target. And the reason I'm mentioning this is because if you are also then doing something where you're being able to click and you're doing your raycasts to actually pick up what you're clicking on, if you don't turn off that raycast target, what can happen is all of those raycasts fail, and they're because they're picking up the reticle and they're not picking up the thing in the actual scene that you're looking at. And it's really, really easy to miss that. So when you've got things that don't need to be a raycast target, so they never need to be clickable, just make sure you turn that off. It's going to make life significantly easier. So that's good so far. Now the camera here, it's not going to be working properly yet with Cinemachine because it needs some extra components on here. The easiest way to set that up is I actually just go down to Cinemachine, chuck in a virtual camera, and then delete it. You can see that that's now properly configured, that main camera. It's added in the Cinemachine brain for it. And the other thing I need to fix up is our event system, because I'm using the new input system. So the grapple code I write, I'll set it up to be able to work for either new or old. But because by default these event systems don't set up with the new one, I need to just click that button. And I just want to make sure I should be able to look around, move around, and I can. That looks good. The one thing I might do is, because it does feel a little sluggish, I'm going to adjust the player settings. So this should be the player motor config. And I'm just going to bump up the sensitivities for horizontal and vertical, just so I can look around a little faster. Let's test that, and then we can actually start setting up our grapple system. That feels a lot better. Good. Okay, so in terms of our grapple system, I'm going to create a dedicated folder for it, and that's going to have the particular things that we actually need in it. So we're going to have a few scripts for this. So we'll have grapple system folder. Then I want the actual tool itself. That's going to have most of the logic. So we'll have our grapple tool. Then, because we want to be able to attach something to different surfaces to give them different properties, I'm going to also have a grapple surface. And that grapple surface script, I want to put that onto our general grappleable one. And I want to put that onto our no grapple and our timed grapple and just our other one. And actually, the general one, I don't want it to have the script. That can not have it. So I'm going to move these or rename these just so it's a little bit clear. So we'll call this grapple surface can grapple. And this one will be timed grapple. This one will be no grapple. And this one will be a grapple surface, but it is untagged. So we haven't applied any sort of markup or metadata to it with that script. So that's good. And then the final thing we want to have is just for managing our reticle. So we will have our grapple reticle. And that will go onto this. So that's good. So we can set these different ones up. A couple of them, like the reticle and the actual surface, are really quite straightforward. So I'm going to get those done first, just to have them all cleared and out of the way. So the reticle, the idea behind this is to give the player feedback, to let them know if what they are looking at is something that they can or cannot grapple to. So what I am going to do is, because I know this is linking to an image, so I'm going to do a require component, and it's going to require a Unity .ui and an image. So that has to be there, which makes my life easy in terms of I can then assume that there will have to be a linked image, which means in a wake here, I can retrieve that. So that's good. Don't need to explicitly say that it's private because it is private by default. So that's good. And what I want to expose here is a couple of options to be able to control the different tint colors for this. So I'm going to have a color for if we are currently grappling. And I might make that, let's go for blue. Also have a color for we can grapple, which I'll default to green. And I will then also have one for if we cannot grapple. Now, I'm just using purely colors here for this, which isn't really ideal. What I would want to do if I was using this on sort of an actual like full project is I would look at having both a visual change in terms of an image with quite a different silhouette for whether you can or can't grapple, as well as the color change. So it would actually use both elements to it. Just makes it a fair bit more accessible for people. So that would be the main difference that I would do there, which is actually quite straightforward for us to do. And we can even set up initially some support for that, because what I could do is have a protected sprite, and this would be grappling sprite, and I can rename these. Actually, I might change the name of these around. So these ones have color, like that, and then these have image, grappling like that, and we will just set up one for each of our different ones. So this is our can grapple, and this is our cannot grapple. So that's good. So pretty straightforward for what we need to do with this. We don't need to do anything in update. Start we will populate in a moment, but we want to have essentially a helper that's exposed to be able to be switching between those images. So we're going to have a on grapple status updated. That's going to take in two parameters. First is, are we grappling? The second is if we can grapple. And so then the logic here becomes, okay, well, if we are grappling, then our linked image, the sprite gets set to that. The color gets updated as well. Otherwise, okay, well, what if we can, not in is grappling, but in can grapple? So that's good. So then here, our linked image sprite is image can grapple. Unsurprisingly, the color is that. Oops, not color.a, just color. And then, quite straightforward for the final one, sprite is our cannot grapple. And our color is also cannot grapple. Then all we would do on start is just do an on grapple status updated with, we'll default it to false and false. So that's good. We can configure that in the inspector here now. So I'm just going to set the sprites for all of these. So this means that we could very easily have different ones if we wanted to, depending upon the particular state. So that means we'll get the tint, and we'll also get the image able to be changed, which always a good combo to do that. So that's all we need for the reticle. That's done. The surface doesn't currently need to do a lot. The goal behind the surface is to give us a bit of options in terms of how we actually build up our levels using this. Because we could allow grappling to anything by default, and we apply this surface to make areas not able to be grappled. So we could only mark up things that we want to have, not be usable. Or alternatively, we could make it that we can't grapple to things by default, and then we have to apply surfaces to enable it. So having that surface script just allows us to support things like making it opt-in or opt-out, which gives us a bit of flexibility for how we set up our levels. Also gives us a place where we can store things like, for the timed surfaces, how long can you actually grapple to it? So it means that you can have different surfaces that behave differently, which is good. We could also later on do further things that change how that actually works for grappling to that surface. For now, we won't do that, but just the reason for setting this up is to support that sort of future use cases. So what I want to have here is firstly an enum. So this is for the surface behavior. So we have a few options here. The default is that we can grapple. We'll also have the option for it being a timed grapple, or that it cannot be grappled. And because we're setting it up like this is something where we could change this dynamically at runtime depending upon what's happening, which is cool. Then I'm going to have my serialize field for the surface behavior. So this is our surface behavior. Now for a timed one, I need to have a control for what that actual time limit is. So this is something I want to have accessible to other things. So this is why I'm going to use this approach of making it a property. So we have our float time limit, publicly gettable, but protected on the set, and I'll default it to 10 seconds. So that's how long we can be grappled to that surface. Going to set up a couple of helpers. So a can grapple property, which all that is going to do is return true if the surface behavior is not cannot grapple. I want to have another helper one for if it has a time limit. And that's a straightforward one of, okay, well, is the surface behavior a time grapple? So that's good. And then we actually don't need anything in start or update. That's all we currently need for our surface. As I said, the idea behind this is a little bit of future-proofing to give us the ability to add further things later on if we find that we have a need to and we have use cases for it. For now, we don't, so we're just keeping it simple for now. But I can configure those surfaces now. So save everything. I can grapple surface. Well, that's already good. Its default is what we want. The timed grapple, we will change that to timed grapple. And then the ungrappleable one, we change that to cannot grapple. Actually rename that object there just to make it clearer. Okay, so that's good. So our surfaces are marked up. We've got one surface here that we've not applied it to, and our plane we also haven't applied it to. So that's good. So now we can implement the actual grapple tool itself. So it's also going to need a few things. What I'm going to do is I'm designing this to work with a rigid body. So I want to require that there is a rigid body present, and that will be a thing that I retrieve in our awake. So we want to make sure we've got that by default. So that's good. So then there's a couple of settings that are just general ones for how the grappling will actually work. So one of the options is if we're permitting the grapple by default. So permit grapple by default, we will say false. Then I want to have some options in terms of the maximum range that we can actually do this at. So max range, for now we'll say 50 meters. When we're identifying somewhere to grapple, we're needing to do that by doing a raycast. So I want to have it that we have a layer mask so that we could mask in and out different areas, because you might want to have all of your grappleable things in a particular layer, for example, or filter out certain things for when we're doing that raycast. So we want to have support for being able to configure that layer mask. But we'll default it to all layers, which we do that by doing the ~0. We want to, when we're grappling to something, we are pulling ourselves towards it, but there is going to be a point where we want to stop that. So I'm going to have essentially a halt distance. And we'll set that to be just 1 meter. Actually, I might just make that permit by default, because it doesn't really need to be having grapple in it. I'm keeping grapple in this just because I wanted the names to be unique there so I don't run into issues. So that's good. I'm going to have, and these are, we'll group these, so we have our header, common settings. Going to have down here our events, because we want to be able to provide notifications for when different things happen. So I want to have an event for not an event queue system. Autocomplete is not being my friend there. So we want to have an event for when we began grapple. Now, the reason I want events for beginning and ending is because when we are grappling, we kind of need to make sure that the player controller that we're using knows that something else is controlling it, because otherwise the player controller is going to be trying to control the movement, and the grappling needs to take it so that the grapple tool is actually more the one controlling it. So that's why I want to have these events for beginning and finishing. I also, to make sure we've got the status information coming through for the reticle, I'm going to have a one here, and this is going to be our update grapple status. So that event, this event, will be able to directly link up to our reticle. So okay, so far so good. We want control though over how the grapple tool moves us towards the particular thing, and I want to support a couple of different movement modes. So I'm going to have an enum here. And in terms of options, I'm going to support 2 initially. One will be constant time. The other will be constant speed. So the idea is, depending upon how we want it to feel, we might want it to always take the exact same amount of time to get to a location, or we might want to make it always move at the same speed. I find that the time one feels a little bit more intuitive for the player, but it's going to depend very much on what you actually want in your particular game. I'm just wanting to make sure that we've got support for both options. So I'll have that here. Movement mode. And that will default to constant time. So then we need some specific settings for our actual movement modes here. So I need one for movement mode, constant time, and unsurprisingly, what we need is what that actual time will be. So this will be movement, time to reach, and that's going to default to, I think, 1.5 seconds. You know, it's testing, felt about right. Then we need another one for, okay, movement mode. And this is our constant speed. So we have another setting here. This will be movement. And this is our speed. So about 5 meters a second works pretty well for that. Feels about right with the time. So that's good. Now, one thing that we might want is to be able to control having a little bit of an arc to this. I won't implement the arcing initially, but I want to have a little bit of support for it. So I want to have some options here for movement arcing. And we'll have a serialized field, float, and this will be our arc height, which we might say 2 meters. But I'll also have a boolean to control if that's enabled. So enable arcing, which I'll default to off. So, okay, whole bunch of settings, lots of things that we need to get implemented, but we've got to actually start building up our actual logic here for this. So, in terms of where to begin, I generally think a good spot to begin is from sort of the user interaction point of where they're actually starting with doing stuff. So what I'm going to do is begin with in update. So we're going to have our update function, and I want to check firstly what sort of inputs I've gotten. I'm going to bind this to the mouse input. And I want to make this so that it can work for either the legacy or the current input system. So what I can do is a F enable legacy input manager, and an else, and an endif. So with those in, we can now implement our actual specific logic for the particular different sides of the input system. So for with the legacy one, it's quite straightforward. So the settings we'll have here will be mouse down this frame. And for the legacy one, what we're doing is doing get mouse button down. That. We have two other ones that we want to check. So we want to look for if the mouse was up this frame, which for that, rather than get mouse button down, we check get mouse button up. And then we also just have one for is it still down. So because the idea will be we press the mouse button and we hold it down, and while we're holding, we're still grappling. So we kind of need to know those three states of mouse went down this frame, mouse is still down, mouse has gone up. So for that final one, we just check get mouse button. So then we want to use these exact same variable names with the section that's for the new input system. However, how we retrieve these is quite different. So with the new input system, it would be Unity Engine, input system, mouse, current, left button, and was pressed this frame. So it's a little bit more verbose. For the mouse up, it's quite similar, except it was released this frame. And then for mouse down, what we're looking for is pressed. So this gives us something where we only have a small chunk of code that needs to care what input system we're actually using, and everything else is able to just work with those variables. So it keeps things a little bit more sort of clean and neat for the rest of the code, which is good. So, okay. Then in terms of our actual logic, we need to check, okay, let's work through the process of, okay, what's the criteria for us starting grappling? Well, one thing would be if the mouse has gone down this frame, but we also need to know if we're currently grappling. So that's another setting I need up here of keeping track of if we are currently grappling, which I'll default to false. Because if we're already grappling, then we shouldn't be starting a grapple. So if the mouse was down this frame and we are not currently grappling, then I want to attempt to start a grapple. Now we don't have this function yet, and that's okay, but we have an attempt to start grapple. So that will go here. We'll have a protected void attempt to start grapple like that. So that's good. Now we've got other options though, because, okay, what if the mouse has gone up this frame and we were grappling? Well, we need to stop. So we would say, okay, well, if mouse is up this frame and we are grappling, then I need an attempt to stop grapple, which will also be a protected void like that. So that's good. That's two of the options that could happen. The other option is, okay, well, we could be grappling and the mouse is still down, and we might actually be doing a timed grapple, so we've run out of time, so we've reached our expiry. So I'm going to also keep track here of if we have essentially an expiry time. So our current grapple, might make it our current target expiry time, which I'll default that to -1 initially. So -1 indicating that our target does not have an expiry time. So if we're grappling and the mouse is down and we have an expiry time that's valid, then I need to check what is happening with that expiry time. So are we needing to actually end the grapple? So firstly, I would update this so the time changes. Then I would check if that is now, I would check if that is less than or equal to 0. And if it is, don't actually need braces for this, because if it is, we should actually stop the grapple. So those are our three main input cases there of looking to see if we should start grappling, looking to see if we should stop, and looking to see if we are grappling and we have an expiry time, and then updating that and checking to see if we need to stop. So this is sort of our key three states that we need to be working through there for that. Then we need to provide our output data for the reticle. We can do that here. So if we are grappling, then we can invoke this, First argument is if we are grappling, which will be true. And the second one is whether we can grapple, which, while we're already grappling, we kind of can't. Then the other option is, okay, I need to know if I actually can perform a grapple. Which, the logic for testing, can I perform a grapple, we're going to need to do that in our attempt to start grapple as well. So we've got a couple of use cases for a function to essentially tell us, okay, can you currently perform a valid grapple at this stage? So what I am going to do is I'm going to set up a function, and the job of this function is going to be to tell us if we could grapple. So this is going to be a protected, and it'll be a bool function. So we're going to say check if, actually I might make it attempt to find grapple target. And what this will output is it can output a grapple surface. And because it's actually useful, I want to also have it be able to output the location. So out found grapple location, like that. So for now, I'm just going to default those like that. We'll come and populate this later, because what I would do in our update then is, okay, we're going to have found surface here. We're going to have a vector3 found location. Then I have a bool could grapple. We do our attempt to find grapple target, output our surface and location. Then we update the grapple status. That gets invoked. Now we are not currently grappling, but we can output the could grapple. So that's good. That means our reticle should be properly up to date, which is excellent. So we can implement our logic for starting and stopping the grapple. I'm going to implement the start logic first, because, unsurprisingly, that's going to make use of this attempt to find function. So I'm going to do our attempt to find grapple target. Now with this, while I'm grappling, I want to actually cache the target and the target location. So I'm going to set up here grapple surface, current target, and the surface. I'll just explicitly make that null. We'll also have a vector3 current target location, and just make that explicitly vector3 0. The reason I want to do that is because then here I want to populate those like that. We just need to make sure we put out here. So, okay, that's good. If we get to this point, we know that we have a surface potentially retrieved, because this might not retrieve an actual surface, which is okay, because some things won't have a surface, but if we're enabling grappling by default, that's fine. So what I need to check is, okay, if we've found something and we've got a surface, is that surface a timed one? So, okay, if our current surface is not equal to null, then what I would do is our grapple, there's our expiry time. There we go, current target expiry time. So we can go and say, okay, well, if our current target and the surface has a time limit, then we use that time limit. Otherwise, we make it -1, so it's an infinite amount of time. Otherwise, we just default it to being an infinite amount of time. And we could actually clean this up a little bit further, make this a little bit shorter in terms of the code by checking, as long as we've null checked here, because expressions in our if statement get evaluated left to right, as long as we've null checked here, we can then assume that that is valid. And that will actually shorten then this to that. So, okay, we've populated our target and the location. We've populated the expiry time. We want to, because we're needing to move, it can be really helpful to keep track of things like the start location we were at for the grapple and how long we've been grappling. So what I'm going to also keep track of here is a vector 3, and this will be our grapple start location. Again, default to 0, and we'll also keep track of time grappling. And because these are kind of more working ones, I'm going to move them up to here. So that looks good. So what we would do down here then is, okay, well, our grapple start location, we want the position from the rigid body. We want to store our time. So our time grappling is 0. We can set is grappling to true. And we invoke our event. So, okay, that's good. We've got everything kicked off for the grappling happening. For stopping the grapple, that's actually pretty straightforward. There's not too much we need to do with that. So we set the grappling to false. We invoke our finished event. We also clear things like our current expiry time goes to -1. The surface will null that out. Location, get rid of that. So we just clear all of these different things, and time grappling, reset that as well. So we just reset and clear everything there. It just makes it that we're leaving things in a very clean and neat state. So, okay, that's good. We want to get this attempt to find grapple target function implemented because this is a really important one. So, okay, I'm going to have a bool be target found, which I'll default to false, and we return that here. Then, in terms of what I need to do. So what I need to do is I need to do a raycast. So firstly, I'm going to construct my scene ray. So I can go to my main camera and I can use screen point to ray. And I just give it a new vector 3. So for the center of the screen, I can access screen width. That's the X. Screen height, halved as well for the Y. And Z is just 0. So that gives us a ray that will be coming from directly under that reticle that we've positioned in the center of the screen. So that's good. Then we'll have storing of our hit result. And what we do is we do a physics raycast. We can give it the scene ray. We give it our hit result. Then we need to give it our max range, our layer mask. So that's the grapple layer mask. And I specifically want to ignore trigger volumes. So, okay. If that returns true, we know that we've hit something. So then what I can do is say, okay, is this actually a valid thing? So I'm going to just have stored here, Grapple Surface, found surface, which will default to null. And then I would say, okay, well, if hit result, collider, and on its game object, I want to try and get a grapple surface component and put that into found surface. So if that was successful, then that means I have found an actual grapple surface bit of markup on it. So I can check, okay, well, I've found surface, and if we can grapple, then target found can be true. Our outfound surface can be our found surface. So we can populate all of that. So that's good. If it's one that we didn't find any of that, so if that try get component failed, then I can check, okay, well, is it enabled by default? Permit by default. If permit by default is on, then we can say that valid target or target found is true. So we only consider it valid if it was a surface and that surface permits grappling, or if we're enabling it by default. And then all I would do down here is if target is found, then outfound grapple location is our hit result and the point. So I could populate that hit, that location always in here, but I specifically only want to populate it if I actually found something, just so that it's consistent in terms of I'm only outputting things when I know that it's actually valid, is just sort of a better way of actually doing it. So, okay, we've got stuff for being able to start the grapple. We've got stuff for being able to stop the grapple. What we don't have is actually moving us towards it. So what I'm going to have is in fixed update. Again, we don't need private for that. What I'll check is, okay, if we are grappling, then I'm going to have a tick grapple, like that I pass the delta time into. And then here, I will set that up down the end, I think. So have a protected void tick grapple. So the reason I always pass the time in like this, rather than just using time.delta time everywhere, is this makes it easy if I want to ever do any time dilation effects on stuff. So that's the main reason for it. It just makes doing time dilation way, way, way easier. So, okay. There's a bunch of things we need to do in this. There's some general stuff to do in terms of, okay, well, the time grappling, let's update that because that's important. So, okay, we handle that. The other thing that is going to be useful to handle here is we have that halt distance. So I'm going to calculate a vector to grapple point. And this is going to be our current target location minus the position from our rigid body. The reason I do that, rather than doing transform position and using the one from the rigid body, is because this is running in fixed update, which means the rigid body's position and the transform position can be different. So when you're doing physics stuff, good to use the one from the rigid body like that. It works a little bit more reliably, especially if you're doing collision checks. Then I want to check, I'm going to get from that the distance to grapple point squared and that is the 2 vector to the grapple point square magnitude, because f that distance is less than or equal to halt distance squared, then I just want to early out. So, because at this point we can't move any closer. Now we get to the core part of the logic of, okay, the different movement modes. So F movement mode is, and we'll do constant time first. It's actually the easiest. So with constant time, firstly, we grab out our progress. So that is our time grappling divided by our movement time to reach. So we get our time spent grappling as a percentage of the time to reach. And what I would do is, because we want to make sure that doesn't go out of bounds, I'm going to do a clamp 0 to 1 on that. So that's our progress. Then what I want to do is, for supporting arcing, we'll have our current arc height. So F, actually, sorry, that's enable arcing. So F arcing is enabled. Then it's our arc height times by, this is kind of an easy way to give sort of an actual curve to this. We do sine of pi by the progress value. And that will give us just a nice curve that goes up. We could do further things to scale that if we wanted. So otherwise, arcing isn't enabled, and we just set that to 0. So getting our new position then, what we do is, firstly, we do a vector 3 lerp, and we do a lerp from our start location to our current target location and progress. Now that's going to move it along the straight line, but then we need to apply the arc aspect to it. So what we add to that is a vector 3 dot up multiplied by our current arc height. So that's good, because then all we do is say, hey, linked rigid body, I want you to move position to that. So the constant time one is much more straightforward because we are essentially lerping just along a line. The constant speed, we kind of still are as well, but we are going to work with it a little bit differently. And we could convert the speed one to a time, but if you maybe have wanted to support moving things, that gets more complicated. So I am going to approach the constant speed one in a way that if you needed to handle more complex scenarios, that's going to be doable. So our process is similar in that initially we want to get a progress value. But because we're moving at a constant speed, and because we want to allow for sort of it to be a little bit looser, we want to base it off of where the thing currently is, I need to reverse engineer from our current position to where we actually are in terms of progress. So I'm going to have a vector 3, so vector to current pos, and that is our linked rigid body position minus our grapple start location, and that looks good. So we've got that, and what I do is I say, okay, well, I want to do a vector 3 dot So we're using the dot product. So we do a dot of the vector to our current position against the vector to the grapple point, but normalized. So the reason for that is what that is doing is we have our vector that's directly to the target point, and we are projecting our current location onto that to figure out how far along it we are. So that's going to give us a distance in meters. So then to normalize that, what we would do, and we'll see this in a second, so distance vector is that. So then our progress becomes, we'll do the same mathf clamp 0, 1, and it's the distance along the vector divided by the square root of, and what we want is the actual total. Actually, we can just use the magnitude one here, because what we want is we divide that by our current grapple location, so where we're heading to, minus the start location and the magnitude of that. That is going to give us a value that goes from 0 to 1. I'll actually put that there, that'll make it a little bit neater. So that's going to give us a value that will go from 0 to 1 based upon how far along that actual vector we are. So that's good. That's going to work quite nicely for us. So that means the arc height, we can actually work that out pretty much the same way. You can actually rename that to desired arc height. Because it's a little bit more complex for the speed one. So we've got our desired arc height. Now we need to actually get our current arc height, because we could be at a fairly different position to what we expect. So what I want to do is figure out where we currently are along that straight line between the start and the end. So vector 3, so this is our base point, and we'll be at some height above or below that, likely above it. So our base point, we get that from a vector 3 lerp of our start location to our current target location with that progress. So that's good, because then I can get our current arc height. Current arc height. If we're enabling arcing, then what we do is we do a vector 3 dot dot of our linked rigid body position minus the base point, and we dot that with vector 3 dot up. So that's good. That gives us our desired and our current, which we can use then to figure out the vertical velocity to add. Because how we actually control the movement is we don't do a move position. In this case, we say our velocity. Well, we need our vector to the grapple point, which we already have here. So we have our vector to grapple point, we normalize that, and we multiply it by the speed. Now we would need to offset that for this arc height difference. So what I'm going to do is initially not actually have anything for that. So we're going to have a vertical speed, which I'll default to 0. I just want to have it linked in here, but not actually doing anything yet. So vector 3 up times vertical speed. Something to, whoops, that also should be 0. Something to watch for when we're working with these. Because this is a velocity, we don't do any scaling with delta time. So we just actually directly use the speed because the scaling with time will just happen automatically. So, okay, that's good. We want to figure out that vertical speed, just to make that a little neater. What I want to essentially have is it be calculated based upon the difference between our desired and current. So what I would do is have something like our desired minus the current, and generally the term for this would be a scale factor. It's not really a speed. So this would be our movement, and we'll call this our vertical error scale. So what we're building here is a very simple version of what's known as a control system. So very, very simple control system. And what we do then is here, this one only applies for the constant speed one, and we'll default that to something low. So the idea behind doing the speed one like this, I could very easily just do it via move positions. I could do the lerps, everything like of that. The reason I'm doing it this way is just because, say you wanted to then do something more complex again, where you were working instead with, having variable speeds, having accelerations, having logic here where you can do things like reverse engineer from a current location to, okay, how far are we progressed through the grapple, is really handy. So that's why we've done it this particular way. So that looks good. What I can then do is I can hook a bunch of things up. So our player doesn't have the Grapple Tool currently. We're going to give them the Grapple Tool. And then the layer mask, I want to get rid of everything from default. What you specifically use in your project will be very dependent on your particular project, but that's what we want for this. So now that I've added that script, I want to link up these events because I need to be able to tell our character that we're doing custom movement. So I've got this is doing custom move that we turn on when we begin a grapple, and we turn it off when we have finished the grapple. So that's good. And then for updating the grapple, we just link that over to the reticle, and that's got the status updated. So that's good. So if we save that, and then what we want to check firstly is, okay, we're not getting any errors. The reticle is currently red, which it should be. It stays red when I look at one that I can't grapple to. The grey one also stays red, but it goes to green as soon as I look at the timed one. Or if I look at the one that I could grapple to as well. And then if I press the button and hold it, then I get brought over to the top. Can't grapple to the ground. And as soon as I let go of the mouse button, it stops. And with like of this one, if I grapple here, I can grapple through it. So we might need to, update our collision checks a little bit. So we do find when we try to grapple to ones, we do get a bit of bouncing and jittering there. So what we can do is, once we reach this point where we can't move any closer, because other things could impact us at this point, and so we kind of don't want to get knocked around. So what I'm going to do is have a boolean up here. Bool be reached grapple end, which I'll set to false. And I will also, when we start grappling, make sure that's back to false. Do the exact same thing here. And then in our tick logic, okay, if we've reached the halt distance, we set that to true. And then all I will do is if that's true, we return. So as soon as we've gotten close enough, we then don't try and actually keep doing any further movement. So that should be better. We try now with that logic to actually sort of freeze things a little bit once we get to the end. We can try, we'll grapple here, and we do find we still actually fall. So what we should really sort of do in this case is, because we want to be stopped at this point, I'm actually going to set the rigid body velocity to 0. And I'm going to do that anytime we're sort of ticking, just so if there's anything external that's acting on us, that it no longer can. And what I will also do is I will actually store off our position. So I'm going to set up here basically our end position to lock. Then down here, I will, when we've actually done this, I'm going to cache off what our position is at that point. Because we're grappled to there, we want to stay stuck to there. So I'm going to say linked rigid body. We do a move position just because we want it to properly go through the right checks. Then let's test that. We'll be able to head to there, and we stay nicely locked in place. We let go, and it falls. Timed one, we get here, and we can stay holding on for a little bit. It'll get to the time limit, and then it should kick us off like that. So that's good. So that was testing with the movement taking constant time. If we switch over to constant speed and see how that feels. So we want to make sure that works too. So we can move here. That works nicely as well. We can interrupt. So that's good. So let's turn on the arcing. I'll leave it on constant speed for now and enable the arcing. And I might make it a bit more of a pronounced arc. This just sort of more matches, I think, how people expect it to work. So we might not notice it as much with, oops, didn't quite manage to get on top of it. So close. But it should more match people's expectations of how the movement should actually go. There we go. And so we can chain together the movement a little bit as well, because I can get to there. And then pull myself over to here. That's good. And if I change that to, I could switch now just to constant time, just to see how that feels. So same sort of thing. Now, constant time, the arc is a lot more pronounced. So that could be kind of fun. So that's good. I could also test the setting to enable using of the grapple by default, which that should now mean I can grapple to this. Also means I can grapple to the ground. So I can travel large distances like that, which is kind of cool. So we have our grappling system up and running. We can configure different surfaces to be able to support grappling or not. We could also do further stuff later on there for those surfaces being able to adjust the location that you're actually grappling to or how the grapple itself behaves, which is cool. The tool, we've got a couple of different options there in terms of how the movement mode works, which is also good. Makes it a bit more flexibility there in terms of what we do with that. So dive in and experiment with this, see what kind of things you can create, see what sort of things you might want to add to this. Thanks folks, hope you found the video interesting and helpful. If you have, chuck in a like and subscribe, really helps out, it's really appreciated. If you're looking for the code for the project, the code is available, there's a link in the description below. There's a couple of links there actually. One is to this sort of starting version of the project. There's a link to the character motor package stuff that I'm using in this as well. And there is also a link to the completed version of the project. You can use any of this code in your own projects, commercial or non-commercial ones. If you've got any questions, chuck those in a comment below. And if you're looking for other ways to support the channel, then I do have things like super thanks enabled as well. But until next time, bye.